There is a story that keeps getting told in glossy science fiction films and popular magazine covers, and it is a story built entirely on a comfortable lie. The lie goes something like this. Mars is out there, waiting. It is cold, yes. It is dusty, yes. But with enough engineering willpower, enough human ingenuity, enough sheer determination, we can simply pack up our things, ship ourselves across the void, plant some greenhouses in the rusty dirt, and begin a second chapter for the human species on another world. It sounds wonderful, it sounds heroic, and it is, almost without exception, completely, fundamentally wrong in ways that the physics will not forgive. I want you to stop thinking about Mars the way a movie poster makes you think about it. Stop picturing the lone astronaut standing on red dunes with a dramatic orange sky and a look of triumph on their face. That image has nothing to do with the real place. The real Mars is not a second home waiting to be settled. It is an execution chamber built by planetary physics, and the physics has been perfecting its design for 4 billion years. Let me give you an analogy that captures this more honestly. Imagine you want to go camping. You take your best canvas tent, you pick the absolute highest point of Mount Everest, and you set up camp there. Now suppose someone takes that entire mountain, that peak and all of it, and drops it inside an enormous industrial vacuum chamber, the kind used for manufacturing satellites, where they remove almost every molecule of air from the room. And suppose the temperature control is locked permanently at roughly 60 degrees below zero on a typical day, with nights dropping down toward 140 below. And then, just to complete the picture, someone wheels in a massive, unshielded X-ray machine and points it directly at your little tent, and simultaneously pumps fine, jagged, electrically charged glass powder through the air valves and lets it drift freely around you. Now ask yourself how long your camping trip lasts. This is not a dramatic exaggeration for entertainment. This is a reasonably faithful description of what a human being faces on the Martian surface, and no amount of enthusiasm changes the machinery that makes it lethal. To understand why, we need to go down into the actual physics. And the first thing that kills you, the very first thing, is the air pressure, or rather the near total absence of it. Here on Earth, the atmosphere presses down on every square centimeter of your body with a weight equivalent to about 1 kilogram. You do not feel it because your body evolved inside that pressure, and everything in your biology is designed around it. That pressure is not decorative. It is doing something absolutely critical. It is keeping your bodily fluids in a liquid state at normal body temperature. The boiling point of a liquid is not a fixed number. It is a function of pressure. Lower the pressure, and the boiling point drops. This is basic thermodynamics, the Clausius-Clapeyron relationship, describing precisely how phase transitions shift with pressure, and it is completely merciless in what it implies for a human body on Mars. The Martian atmosphere exerts a pressure at the surface of roughly 600 pascals. Earth's pressure at sea level sits around 101,000 pascals. Mars gives you less than 1% of the pressure you are standing in right now. At that pressure, the boiling point of water falls to somewhere around 0 degrees Celsius, which is the same temperature at which water normally freezes. This creates an extraordinary situation. Somewhere between roughly 19 and 20 kilometers of altitude above Earth's sea level lies what aerospace medicine calls the Armstrong limit. Above that boundary, the ambient pressure is so low that water boils at the temperature of a living human body, which sits at 37 degrees Celsius. Mars sits permanently and catastrophically far below this limit. Step outside without a rigid pressurized shell, and the moisture coating the inside of your lungs, the fluid in your eyes, the water in every soft tissue, does not wait around to decide what to do. The phase transition happens immediately. The saliva on your tongue begins to vaporize. The moisture in your airways begins to expand explosively as it shifts from liquid to gas. This is not metaphor. This is kinetic molecular physics operating as it always does when pressure conditions change, and it does not take long, not long at all, for biology built for a pressure of 101,000 pascals to fall apart when it encounters 600. A pressurized suit addresses this problem, but only as long as the suit remains perfectly intact, which brings in an entirely separate set of physical problems we will return to shortly. The second truth of Martian physics reaches down deeper than the surface. It reaches into the dead interior of the planet itself. Earth has a beating heart. It is not a metaphor. The interior of our planet remains hot and partially molten, driven by the decay of radioactive elements and the residual thermal energy from Earth's formation. This hot, liquid iron outer core is spinning, and it is being driven by convection currents, layers of molten metal circulating as heat moves outward. A spinning, electrically conducting fluid generates a magnetic field through a mechanism we call the dynamo effect. This is not complicated in principle. Moving charge produces magnetic fields. This is Faraday and Maxwell, and it is the same physics that runs an electric generator. Earth's liquid iron core is, in a very real sense, a natural generator on a planetary scale, and it produces the magnetosphere, that enormous invisible magnetic bubble surrounding our planet. The magnetosphere is not primarily there to make compasses work. Its primary function is to deflect the constant assault of charged particles streaming outward from the sun at hundreds of kilometers per second, what we call the solar wind, as well as far more energetic cosmic rays arriving from deep space. These particles carry enormous energy. Without the magnetosphere intercepting and rerouting them, they would slam directly into the upper atmosphere and, on longer timescales, physically blast away gas molecules one by one through a process called sputtering, where incoming particles transfer momentum to atmospheric molecules and kick them off into space. Over millions and billions of years, an unshielded planet loses its atmosphere this way. Mars is small. Its diameter is roughly half of Earth's. Its mass is about 1/10 of Earth's. Small planets cool faster. The physics of heat loss from a sphere scales with surface area, but the heat production scales with volume. As the ratio of surface to volume grows larger for smaller bodies, they radiate away their internal heat more efficiently and more quickly. Mars lost its internal heat. Its liquid iron core solidified. The dynamo stopped. The magnetic field essentially vanished billions of years ago. The solar wind, no longer deflected, began directly stripping the Martian atmosphere, molecule by molecule, carrying it off into space. We can measure this stripping in real time. The NASA MAVEN spacecraft flew through the interface between the solar wind and the remnant Martian atmosphere and measured ions escaping from the planet at a rate of roughly 100 grams per second. The process is ongoing. It never stopped. What remains on the surface today is not protected by any global magnetosphere to speak of. High-energy particles from the sun and from cosmic ray sources arrive continuously at the Martian surface with almost no shielding. The radiation dose at the surface of Mars is estimated to be somewhere between 40 and 50 times higher than typical background radiation on Earth's surface. Cosmic rays and energetic protons do not just cause cancer over time through statistical DNA damage. At sufficient intensities, they break molecular bonds directly, disrupt cellular processes, shatter chromosomes. A human being on the Martian surface without extraordinary shielding is receiving a radiation dose that exceeds the annual occupational limit for a radiation worker within a matter of days. This is not an engineering problem waiting for a clever material solution. The problem is deep in the planet's history, in the cooling physics of a small, rocky body that simply did not have enough thermal mass to sustain its protective dynamo. The third truth is the one that feels almost personal in its hostility. It is in the dirt. Martian soil is not like dirt on Earth. Earth's soil is full of organic molecules, biological activity, moisture, and a continuous chemical cycling that keeps most of its reactive compounds in stable, less aggressive forms. Mars has none of that biological buffering. Instead, the surface has been subjected to something like a long, slow chemical cooking process. Ultraviolet radiation arrives at the surface with almost no ozone layer to soften it, because the thin Martian atmosphere provides almost no ultraviolet shielding, and there is no active photochemistry generating ozone efficiently in that environment. This intense ultraviolet bombardment drives energetic photochemistry in the surface material itself. The result is a soil saturated with perchlorate compounds, chlorine-based salts in which chlorine is bonded to 4 oxygen atoms in a highly oxidizing configuration. The NASA Phoenix lander confirmed the presence of perchlorates in the Martian Arctic soil at concentrations between 0.5 and 1% by mass. These are not trace contaminants. They are present in the soil everywhere sampling has occurred. Perchlorates are acutely toxic to human biology. They interfere directly with iodide uptake in the thyroid gland by competing for the same transport channel, suppressing thyroid hormone production, which regulates metabolism throughout the entire body. Chronic exposure causes hypothyroidism. Acute high-level exposure can cause far more rapid systemic dysfunction. Martian soil is not something you can accidentally brush off your suit and ignore. It is a chemically hostile substrate. But the dust does not just stay on the ground. The Martian atmosphere, thin as it is, still moves. Windstorms on Mars, while far less forceful than Earth storms due to the low atmospheric density, still pick up and carry fine particulate material, and Martian dust is not fine in the sense of being smooth or inert. It is composed of extremely fine particles of silicate minerals, the sort of jagged, fractured material that on Earth we associate with industrial silica dust hazards, except with the additional property that in the extremely dry, ultraviolet-rich Martian environment, these particles accumulate significant electrostatic charge. Charged dust particles cling to everything. They embed in seals. They work their way into mechanical joints. They coat optical surfaces. And if they are inhaled, they do not behave like ordinary atmospheric dust. Jagged silicate particles of submicron size that penetrate deep into lung tissue cause a progressive, irreversible inflammatory destruction of lung architecture. The combination of perchlorate chemistry and charged silicate particulates makes the Martian regolith one of the most hostile material environments a biological organism could encounter. Now, I want to be careful here not to end this on a note of despair, because that would be missing the most important thing. None of this should make us feel smaller. If anything, it should make us feel the full weight of something extraordinary. We live on a planet that managed to get every one of these parameters right. The pressure is right. The magnetic field has been maintained for billions of years by a still active liquid iron dynamo. The chemistry of the soil is buffered by an enormous biosphere that continuously recycles reactive compounds into stable forms. The ozone layer intercepts the ultraviolet radiation that would otherwise sterilize the surface. The atmospheric pressure sits perfectly in the range where water remains liquid across a wide temperature band at the surface, and where organic molecules can do the extraordinarily delicate work of assembling themselves into cells, and cells into organisms, and organisms into the thing that is now reading these words. The physics that makes Mars uninhabitable is the same physics that makes Earth staggering in its precision. When you understand why Mars cannot support life, you simultaneously understand why every breath you take is the output of 4 billion years of planetary machinery running at an extraordinarily narrow operating window. The real wonder is not out there in the dusty red nothing of a world whose core stopped beating long ago. The real wonder is here, in the impossible balance of pressure and temperature and chemistry and electromagnetic shielding that allows a bag of liquid-filled organic molecules to walk around on a rock. Look up at the stars and try to figure out how all of this works. That is the thing worth protecting. That is the thing worth understanding deeply, without comfortable illusions about simply packing up and moving somewhere else when this one becomes inconvenient.